So we're looking to put this into vertex form, which will make it much easier to graph. So vertex form, let's think about how we're going to do that. So first of all, we'll put some brackets in. And we'll leave a space there, and we'll put the 24 out there. And we look at it and haven't changed anything about this equation other than add some brackets and a space. There's still an x squared, there's still a 10x, and there's still a 24. But this leads us to our next step. We want to make a perfect square out of this. And so the way to do that is we just say 10 divided by 2 is 5, and 5 squared is 25. And now we have a perfect square. And we can go down here and we can say x plus 5 all squared is the exact same thing as that. And we can double check that. The first term, if we multiplied this or squared this x plus 5, x squared, sure enough. Then we would have two middle terms, 5x and 5x, and they would add together like terms to become 10x. And then our last term, 5 squared, would give us our 25. So, indeed, it is the same. Now, the thing is that we have to go back and think about this because we added a 25 to the equation, and you can't just add a 25 and expect that the equation's the same, unless we subtract 25 out at the end. So now it's the same equation, but we have a plus 25 and we have a negative 25. And the plus 25 is a little bit of a strategic play to get that perfect square. And if we subtract the 25 out at the end, it keeps everything the same, and we just have to deal with it there. So 24 minus 25 is negative 1. And there we go. We have it in vertex form. So next step is to graph it. And so what we would be doing there is we can just draw our vertex. And our vertex is going to be from the origin here, and so we'll just mark those in. From the origin, it's going to be 5 to the left. So 1, 2, 3, 4, 5. And then it's going to be down 1. So there's our vertex. So we can mark it in as -1, and this is -5, and we have our vertex. Okay, so now we can draw in our parabola, and we can also identify, and we can mark this in as -5 and -1, just as identifying the vertex. And then we can stop and say, well, where are those x-intercepts going to end up? Well, we know on our typical one where we have it here, if we go over 1, we go up 1. If we go 1 to the left, we go up 1 as well. So same thing here as if we go over 1, we go up 1. So this must be at -4. And so we can show this as -4 and 0. That's this point here. And over here, we can say this is -6 and 0. And so there we go. We have our vertex identified, -5 and -1, and two additional points there, which are in this case the x-intercepts, and that's all we need to do.